Okay, let's unpack this. You sent us some really fascinating notes on programming structure, and specifically on this big strategic choice.
Right. When to actually use object-oriented design.
Exactly. When and how to really make the most of Ode. We're trying to move beyond just, the mechanics of a class. The goal today is to give you a shortcut for that strategic thinking.
That's the mission, for sure. This deep dive isn't about teaching you Python syntax. It's about giving you a clear decision-making matrix.
A definite yes or no.
A definite yes or no for knowing if OOP is the right tool for the job. I mean, not every problem needs a class, and knowing when to keep it simple saves everyone a lot of time
Hmm.
and frustration.
Absolutely. And we've broken down your sources into what feel like the three core decisions for any developer. First, how do you even recognize a true object, something that actually needs to be encapsulated? Second, that surprisingly blurry line between data and behavior when you're using Python's properties. And third, what has to be the ultimate rule for clean code? Don't repeat yourself.
The famous DRY principle.
The famous DRY principle.
It's all about making informed choices. When you finish this deep dive, you'll be making decisions that the future version of you will genuinely appreciate.
And anyone else who has to read your code.
And any poor soul who inherits your code, yeah.
So let's dive right into that first choice, that first filter. When should a developer stop using, say, standard data structures, your lists, your dictionaries, or even just a simple script full of functions, and start building out full-blown classes? What's the tipping point?
Well, what we found in the source material is a beautifully simple matrix. It's all based on what your program is really focused on. It gives you three really clean paths.
Okay.
So path one, if your entire focus is just managing collections of information, think logging sensor data or config settings, then data is the focus.
Just data.
Just data. And in that case, stick with simple data structures.
Mm.
They're efficient, they're fast, and they're perfectly clear for just pure storage.
That makes perfect sense. No need to build a whole custom class if a dictionary does the job, right? So what if data isn't the priority?
Then you look at behavior. If you just need to perform an action like you take some input, do something to it, and return a result without needing to manage some complex internal state.
Like a calculator function or something.
Exactly, or a function that just, transforms a case of a string. A simple function is perfect, it's clean, it's testable, it has no side effects.
So that leads to the sweet spot for OOP. The territory where classes truly shine has to be the intersection of those two.
That's it. OOP is the right tool when both data and behavior are of equal focus. That's when you have to identify the objects in your problem.
Which could be real things or abstract ideas.
Right, they could be physical things or concepts like a transaction or a user session. And for those, you model both their data, their attributes, and their behaviors, which are their methods.
Okay, I want to push back on this a little, just to play devil's advocate for a second.
Please.
You often hear that OGNA feels verbose. You look at a simple functional script and then its class-based equivalent, and the class just seems to have so many more lines of code. What's the real trade-off there?
That is the most common critique, and it's a fair one to bring up, but we have to counter it right away with the wisdom from the research.
It is.
Code length is not a good indicator of complexity. In fact, sometimes brevity is the most deceptive thing in the world. It can lead to the worst kind of complexity, which is just unreadable density.
You're talking about the one-liner.
Precisely. The
Yeah.
one-liner. It can be a fun challenge, to see how much you can cram into one line, but code that's impossible to follow, even for you, the original author, a week later, is just vastly more complex, even if it's short.
I've been there.
We all have. A longer program with a clear, explicit organization is always, always easier to maintain.
So the complexity isn't really in the number of lines, it's in the tangled logic, the state management.
That's it, exactly. And that gets us to the key strategic benefit of OOP encapsulation. When you bundle data and behavior together in a class, you prevent all these accidental, chaotic state changes from happening all over your program.
I see.
So the more important a set of data is, and the more functions you have that are specific to that data, the more useful it is to use a class to organize and protect it. That's the long-term win. Fewer bugs, easier changes.
That context is golden. So let's move into how OOP actually solves some of these modeling challenges, because this is where that readability argument you made really lands. The sources use a great example of a point and a polygon.
Right. If we look at modeling something like a polygon, a shape defined by its corners, the difference between a functional and an OD approach becomes really stark.
How so?
And a purely functional approach,
Yeah.
you might just represent that polygon as a list of points.
Mm-hmm.
And maybe each point is just a tuple of coordinates like x, y. So you just have a list of tuples.
Okay, a pure data structure, just the numbers.
Correct.
Yeah.
But if you convert that to an OD model, you define a point class with X and Y attributes, and then a polygon class that holds a collection of those point objects.
Ah, okay.
Now, every single time you see a point object in your code, you immediately know its role, what data to expect inside it, and even what it can do, like calculate its distance to another point.
And this gets right at that readability problem, because if I just see a list of tuples in some giant script, I have no idea what they represent. Are they coordinates, RGB colors, vectors? It's totally ambiguous.
That ambiguity is the trap. The research really stresses this point. You can model these things with just data structures, but the code becomes so much less readable because it has no context.
The class is the context.
Class is the context.
Yeah.
It's a powerful, permanent label. It tells any reader this thing is a point, and it knows how to do point things.
And that's the aha moment, right? It's not just about simple modeling. When you get into more complex relationships, like inheritance or how different objects interact, you just can't do that elegantly without classes.
You really can't. And this all circles back to that core principle. Never try to win at Code Golf.
I love that phrase.
Your main goal should always be clarity, not being concise at all costs. If adding 10 extra lines of boilerplate saves the next developer an hour of debugging, you absolutely made the right decision.
No one wins at Code Golf. I think every developer needs that taped above their monitor. Okay, let's transition now to a more nuanced area, because that line between data and behavior can get uncannily blurry. This is where it gets really interesting, the whole discussion around properties.
Right. So traditional OOP, especially in languages like Java or C++ bar, was really insistent on this rule. Never access attributes directly.
Which led to all that boilerplate code.
Mountains of it. You'd have your get name and your set name methods just to read or write a simple piece of data.
And I remember learning that and thinking, why all the hassle? Why not just access the name directly? It felt like pointless overhead. What was the thinking there?
It was all about control and future-proofing. Two huge benefits, really. First, it just standardizes access. But more importantly, using a method gives you a hook.
A hook.
A place to inject logic behind the scenes whenever that data is accessed or set. That logic could be data validation, checking if a value is even acceptable. Or it could be access control or logging.
And the most complex example you pointed out was caching.
Exactly. If calculating an attribute is expensive, say your total cost needs a database call or a complex loop, you only want to do that once.
And then store the result.
If you use a method, you can write logic to check the cache first. You just access the attribute directly. You'd have no place to put that pre-check logic.
But those traditional getName, setName methods feel so clunky. And the sources say they aren't really favored in modern Python. So how does Python give us the best of both worlds, the simplicity and the protection?
Python solves this beautifully with the property function, or more commonly now with decorators. Things like @property and @method.setter. These tools let you define methods, where all your validation or caching logic lives, but you expose them with a syntax that looks exactly like you're accessing a simple attribute.
So you get the clean syntax of direct access, but the moment you try to read or write that attribute, Python is secretly running your hidden method. That's a fantastic facade.
It is, but this is also what blurs that line between behavior and data. So to keep things clear, we have to rely on the noun-verb rule.
The non-verb rule.
You must use explicit methods when the operation is an action of verb. Things like calculateria or submit report.
And properties, which look like attributes.
You use attributes or properties to represent the state of the object. These should always be nouns, adjectives, or prepositions like size, or is connected, or file path. They should feel like simple data.
So what's the definitive rule for that exceptional case? When do I take a simple noun attribute and complicate it by sticking a hidden method behind it?
You should only use a property when that complex computation is involved. Validation, logging, access control, or that crucial caching example. Without the @property decorator, you just wouldn't have a place to write the logics to check the cache.
I see.
But if the data is truly simple, direct access is clearer. Don't add complexity where it's not needed.
That makes it so much clearer. If the data is simple, keep the interface simple. If complexity has to be hidden away for integrity or performance, then you use the property facade to keep that interface looking simple.
Precisely. You're managing complexity without complicating the way people use your object.
Okay, let's shift focus completely now to code maintainability. Because if we're being honest, this is where most developers spend their time. And this might be the most practical takeaway for anyone writing code that needs to last more than a week. Why is duplicate code such a critical flaw?
It really boils down to two nightmares: readability and maintainability. Duplicate code is the result of what we all lovingly call copy-pasta programs.
Copy paste.
You copy a block of logic to extend some functionality instead of refactoring it into a reusable function or a method.
And the result of that initial shortcut is...
A catastrophic mess. The sources put it beautifully. They say you end up with a big mess of tangled noodles of code, like a bowl of spaghetti. And this mess creates an additional intellectual barrier that just slows down everything that comes after.
That barrier is so frustratingly real. I look at two code blocks that are almost identical and my brain just freezes because now I have to answer 3 questions before I can even think about changing anything.
Exactly. Question 1. Are they truly identical or just 95% the same?
Right.
Question 2. If they're different, which one is the right one, the correct version? And most importantly, question 3. If I fix a bug in this block, do I have to remember to fix that same bug in the other 10 places I pasted it?
And you will forget. Everyone forgets.
You always forget one, and that's how you get these insidious intermittent bugs that are an absolute nightmare to trace. The time you saved shitting Sheroll plus C is repaid tenfold in debugging later.
So what's the rule of thumb?
The 3 strikes and you refactor rule. If you see yourself copying a block of code more than twice, that is a screaming sign that the logic needs to be pulled out into its own function or method.
Which brings us directly to the solution that all great developers live by. The don't repeat yourself principle, DRY.
Absolutely. The advice from the sources here is strong and uncompromising. Never copy and paste code. You have to think 3 times before you hit that copy command.
Yeah.
If you have similar logic, it has to be abstracted into a single authoritative source of truth.
A single source of truth.
DRY ensures that if a change needs to be made, you make it once in one place and the whole system benefits instantly.
So what does this all mean for you as you're approaching your next project? Every one of these decisions we've covered, choosing OOP versus a simple data structure, picking a method over a property, sticking to the DRY principle, they all lead back to the same strategic goal. You're trying to create knowledge structures that are clean, easy to manage, and immediately understandable for anyone, anytime.
And to synthesize our core takeaways from all this, your choice of paradigm really just depends on your focus.
Data, behavior, or both.
Data structures for pure data, functions for pure behavior, and OOP when you have to manage both together. And always, always prioritize readability over just minimizing your line count, because short, complex code is way more dangerous than long, clear code.
And use properties carefully.
Use them judiciously, yeah.
Yeah.
To manage that necessary complexity like validation and caching, but hide it behind a simple, noun-based facade.
That brings us to our final provocative thought for you to consider as you step away from this deep dive. We spent a lot of time talking about how properties can blur that line between behavior and data, how they do complex work like validation and caching while still looking like simple variables.
The question for you is this: when you design a new class, how much complexity are you willing to hide behind that simple facade? How much logic can you tuck away, making it look as if you're just directly accessing data before that hidden complexity becomes its own kind of trap?
Where is your personal-professional line? The line between the desire for clean, simple interfaces and the absolute necessity of making sure all that crucial validation and caching logic is still transparent and understandable for the people who have to maintain your code down the road. It's a trade-off that really defines the difference between good code and great code.